Okay, this video is about vector addition, so let's get started. The objective of this video is that by the end of this video you should be able to explain the difference between a vector and a scalar. Then you should be able to describe how a vector is graphically represented. And then you need to be able to explain the two ways that we can graphically add vectors. The first one being tip to tail and the second one being the parallelogram method. So first we have to understand the difference between a scalar and a vector. A scalar is something in which its quantity is fully described by magnitude alone. And by magnitude I mean a number. So if I tell you that I have 35 coconuts, that is a scalar because it's only represented by a number, 35. Okay? In contrast, a vector is a quantity which needs both a magnitude and a direction. 35 coconuts has no direction. But if I tell you that those coconuts are located 5 cabinets to the left, then you have a magnitude, which is 5 cabinets, and then a direction to the left. So let's say we have a jogger, and she goes from A to B, and then backtracks a little bit to C. Okay, so A to B, backtracks to C. We have two questions. First, how far did she travel distance-wise? And then two, how far away is she from the starting point? Okay, distance traveled, we can add up each of those segments and we get 400 meters. Because there's no direction, that's a scalar. But how far away is she from where she started? Well, she ended up 200 meters to the right of A, where she started. So because we have a direction in there, that's now a vector quantity. And a word that we're going to use for that now is displacement from now on. Displacement is how far you are from where you started. So how do we show both magnitude and direction with just one symbol? Well, the answer is an arrow. So an arrow is going to have a tail and a head, and so the length is going to give us magnitude, that number, however long it is, and then the arrowhead is going to show us where it's pointed, and that's going to give us our direction. So how can you tell the magnitude just by length? Well, we're going to do it by scale. So if you have an arrow that you know is 5 meters, then an arrow that is twice as long as that is going to be 10 meters. And no matter where it's pointed, as long as it's the same length, it's always going to mean 10 meters. So length equals magnitude. So what about direction? Well, we have our handy dandy north, east, south, west compass. And so that's going to be what we start out with, but eventually that's not going to be good enough because I'm going to want a little bit more precision. So we're going to eventually move on to just degrees with angles. So if you combine both of those, then you have vectors basically have magnitude and direction, right? So 5 meters west, which is 0 degrees, or 10 meters west, or 10 meters southwest, or 15 meters south. All of those are vectors because they have both a magnitude and a direction. And they must always have both of those. So let's say I want to add vectors because I'm going to walk 5 meters west, then I'm going to walk 10 meters west, and then let's say I walk 15 meters south, and then I walk 10 meters southwest. Where am I going to end up at the end of all of that? Well, I'm going to find that out by adding up all these vectors. So you have the graphical method, which is the first thing, the whole point of this video. And basically we're going to use a scale drawing to find the sum of all these vectors. And by scale, I mean I'm going to have to use a ruler to measure out the magnitude and then a protractor to draw the angle. Okay? So hopefully your pictures look a little bit better than this when you're done though. Okay, so we have two graphical methods, tip to tail and parallelogram. So here's our first one, tip to tail. You simply are going to add them up, tip to tail to tip to tail. So here's what I mean. We walk 5 meters west, and then we walk another 10 meters west. So notice I added the tip to the next one's tail. And then I walked 11 meters south, and then I walked 10 meters southwest. Okay, all I'm doing is adding them up exactly as they look, tip to tail. And then finally, I'm going to connect where I started to where I end, and I get that I traveled total. My displacement from where I started to where I end, right, is 21 meters at 322 degrees if I measured this angle right here. Okay, and how did I get that? Well, I measured with my ruler and my protractor because I measured all those out exactly, and then I can just use my ruler to measure it all out. And then what we're going to call, instead of answer in vector land, we call our answer a resultant because it's our result of all our additions. Okay? So here's your second graphical method, whichever one you prefer. Some like the first one, tip to tail, and some people get parallelogram better. So basically all you're doing is making a box. And here's a picture. You have two vectors. You're going to start them both at the same place and you just draw a box with them. And then, ta-da, the diagonal, when you connect the diagonal, is your resultant vector, your answer. Okay? Here's a common mistake I see a lot of people do. They take their two vectors and they connect the dots. And that is not a parallelogram. If you paid attention in geometry, that is a triangle. So that is not the right way. But if we, instead of connecting the dots, we are using them as guides to make a parallelogram or a box, then we can draw the diagonal and there's our resultant vector. And again, I would just use a ruler and a protractor to measure the length to get the magnitude, and then this angle to get the direction. So both are good. Tip to tail and parallelogram method, you can see both of them make the same resultant vector. Whichever one floats your boat and whichever one you want to use, that's the one you can use. Okay, so hopefully, again, you should check this, your objectives. By now you should be able to explain the difference between a vector and a scalar. You should describe how a vector is represented, aka by an arrow, but what does each part mean? And then you need to explain the two ways that we can graphically add vectors. You need to be able to explain the tip to tail method and the parallelogram method. So come into class and we're going to play around with this more and practice with some real life examples, and you're done.